So artificial variable coefficient is minus 1 and artificial coefficient 2 is also minus 1. And minus 10 into 5 by 4 minus 10 into 1 by 4 will get minus 10. Phase 1 and phase 2 will get the optimal solution as we have constructed in simplex table. So now you can find Cj minus Zj. 0 minus of minus 2 is plus 2. 0 minus of minus 2 is plus 2. Hello my dear students, welcome back to my new session. I am Shweta, Computer Science Faculty, Vidhyaashram College, Mysuru. In my last session, I have discussed question paper problems. So today I will discuss the new topic called two-phase method. If you learned simplex method easily, you can solve this B.C.A method and two-phase method also. So let's get started now. Two-phase method. So what is this two-phase method? As the name suggests, the method consists of two phases, phase 1 and phase 2. So what is the definition of two-phase method? Another technique to solve LPP involving artificial variables. So here we are adding the artificial variable also in two-phase method. Here we have two phases, phase 1 and phase 2. And also it consists of artificial variables. As the name suggests, method consists of two phases. What is the first phase? In first phase, we have to construct an auxiliary variable in such a way that in the objective function, all the slack variable and surplus variables have 0 coefficient, while the artificial variable have minus 1 as their coefficient. I'll repeat. In phase 1, all the slack variable and surplus variable coefficient should be 0, 0, 0, 0, except this artificial variable. So artificial variable coefficient is minus 1 and artificial coefficient 2 is also minus 1. So in phase 1, all the slack and surplus variables have 0 coefficient, while the artificial variables have minus 1 as their coefficient. Max z is equal to 0x1, 0x2, 0x3 plus 0x4 and so on, minus a1, minus a2 such that constraints has equations. So here artificial variable coefficient should be minus 1 and surplus variable and slack variable coefficient should be 0 in phase 1. And next is case 1. In case 1, max z should be less than or equal to 0 and at least one artificial variable appears in the basic variables. So in two-phase method, in phase 1, we have to represent at least one artificial variable at the solution stage. In such case, the LPP does not have feasible solution and terminated at phase 1. And case 2, if max z is equal to 0 and no artificial variable appear among the basic variables at solution stage, in such case LPP has a feasible solution. Goes to the next phase to find optimality. So in phase 1, all the variables value should be 0 except artificial variable. So artificial variable coefficient should be minus 1 and minus 2. So after that we can proceed for next phase. And in next step, in phase 2, to begin with a new objective function is written by taking the original problem in the maximization problem. So in phase 1, all the surplus variable and slack variable values, that means coefficient should be 0, 0, 0, 0. So finally we will get the 0 value in optimality solution. So after completing this phase 1, we have to move for phase 2. In phase 2, what will happen is, so we have to find the original problem in the maximization. We have to take the original coefficient value in objective function. Listen carefully. In phase 1, all the coefficient value should be 0, 0, and in phase 2, all the coefficient should be in a virginal form. So all the coefficient value should be original problem in the maximization. That means in the objective function, all the slack and surplus variables including artificial variables are assigned 0 coefficient while the decision variables retain their original coefficient. So except this slack variable and surplus variable, value should be 0, but other than that, all the value should be in original coefficient value. So this is about your two-phase method. In phase 1, all the coefficient value should be 0, and in phase 2, all the objective function value as in the original form. And in next step, a new simplex table is constructed. As we have studied in simplex method and BACHELOR method, we have to construct a simplex table where artificial variables are ignored altogether. So already I have discussed this concept in BACHELOR method also. So while executing the iteration 1, iteration 2, so one by one we can remove the artificial variable, right? So same method we are applying in two-phase method also. The initial table for phase 2 would be exactly as the solution stage. And now in simplex method is applied to arrive to solution stage and get an optimal solution. So after finding the phase 1 and phase 2, we will get the optimal solution as we have constructed in simplex table. Let's understand with an example problem. Here I have objective function. It is in min-z minimization problem. So all the minimization types should be converted into maximization by multiplying -1 to the objective function. So multiply this -1 to the objective function. So min will changes to max z dash is equal to -10x1 -6x2 -2x3. So this is your objective function now. So now we have two constraints, greater than or equal to and greater than or equal to. If it is greater than or equal to type means we have to subtract the surplus variable with artificial variable. So first constraint is -x1 plus x2 plus x3 minus s1 plus a1. Subtracting the surplus variable with artificial variable. And the second constraint, 3x1 plus x2 minus x3 minus s2 plus a2. Second surplus variable with artificial variable is equal to 2. Now I have converted this inequality into equality form. So now max z is equal to, here I have two surplus variable with artificial variable. So 0s1 plus 0s2 with negative artificial variable. So this is my two-phase method standard form. So in two-phase method standard form, you have to add -1 objective function to the artificial variable. So in BACHELOR method, we have added -m and -m. Because in BACHELOR method, we have to add -m with artificial variable. But in two-phase method, -1 to the artificial variable. Very simple concept. So now it is in a standard form. I can move further. So initial simplex table. First write all the basic variable. x1, x2, x3, s1, s2 and a1, a2. I have these many variables. Now write the coefficient of this objective function. So what I have told you that? So already I have told you that in phase 1, this is phase 1. In phase 1, all the coefficient values are 0 in objective function. So all the coefficient value should be 0 except this artificial variable. Except this artificial variable coefficient is -1 and -1. Except this artificial variable coefficient, all the variables value, coefficient value should be 0 in first phase. And the next step is, here I have two artificial variable a1 and a2. Coefficient is -1, coefficient is -1. So here I am not mentioned any surplus variable, have mentioned only artificial variable. Next write the coefficient of first equation and coefficient of second equation. x1 coefficient is -1, 1, 1 and s1 is -1, s2 is not there, a1 is 1, a2 is not there. Solution and ratio. And next step, second equation, coefficient of x1 is 3, 1, minus 1, s1 is not there, s2 is minus 1, a1 is not there, a2 is 1. First equation solution is 1, second equation solution is 2. First write all the coefficient of equation number 1 and equation number 2. Now you can find the zj value. Zj value is minus 1 into minus 1 means it is plus 1 minus 3. Plus 1 minus 3 is minus 2. And minus 1 into 1 is minus 1. Minus 1 into 1 is minus 1. So minus 1 is minus 2. And minus 1 into 1 is minus 1. Minus 1 into minus 1 is plus 1. Minus 1 plus 1 is 0. And minus 1 into minus 1 is plus 1. And minus 1 into 0 is 0. So plus 1. And minus 1 into 0 is 0. Minus 1 into 1 minus 1 is plus 1. And again it is minus 1 and it is minus 1. Now you can find the Cj. You just observe this Zj value here. So in simplex method, Zj value is always 0 in initial simplex table. In two-phase method and B.C.A method, Zj value is not 0. So now you can find Cj minus Zj. 0 minus of minus 2 is plus 2. 0 minus of minus 2 is plus 2. And 0 minus 0, 0. 0 minus 1, 0 minus 1. Minus 1. Minus of minus 1 is plus 1. So minus 1 plus 1 is 0. Minus 1 minus of minus 1 is plus 1. So minus 1 plus 1 is 0. So this is your Cj minus Zj value. Now you can find whether this value is satisfying the optimality condition or not. So here I have plus 2 and 0 minus 1 minus 1. So it is not satisfying the optimality condition. Now you can check the Cj minus Zj value. So this is two-phase method. In two-phase method we have two phases, phase 1 and phase 2. Now I am solving phase 1. In phase 1, all the Cj minus Zj value should be 0 in phase 1. Till that we have to do the iteration. So all the Cj minus Zj value should be 0. Till that we can move further. So here we have 2, 2, 0, minus 1, 0, 0. So it is not satisfying the optimality condition. So I can move further. So here, so again we have to select the maximum value for getting the key column and key row. So here we have two maximum values. So you can choose any one maximum value. I will select this maximum value x1. So 2 comes under. So x1 is my key column. And you can find the ratio. So solution by key column 1 by minus 1 is minus 1 and 2 by 3 is, so 2 by 3. So you just select the least positive value in the ratio for getting the key row. So least positive value is 2 by 3. So this is my key row. So now you can observe this. Key column is x1, key row is a2. So key row means it is a2 is living variable. And x1 is entering variable or incoming variable. x1 is incoming variable. So in place of a2, I can write x1 because x1 is entering variable, a2 is deleting variable. So in the next iteration 1, I can iteration 1. In iteration 1, I can replace this a2 by x1. So in place of a2, I can write this x2. It is a1 and it is x2. I'll write the basic variables x1, x2, x3 and s1, s2. And now you can observe this. I have deleted this a2 row. I can delete this a2 column in the next iteration. So I am deleting this a2 column also. So I'll write only a1 and solution and ratio. Now again all the coefficient value is 0 only except this artificial variable. And now a1, a2 is replaced by x2. So here x2 coefficient is 0, a1 coefficient is -1. So here you can replace the old values. Key row is a2, you can find the key row values 3, 1, minus 1, 0, minus 1, 0, 2. 3, 1, minus 1, 3, 1, minus 1, 0, minus 1, 0 and 2. So using this key row values, you can find the new value for x2. So how to find the new key row values? Here you just observe this key element is 3. Common for both key row and key column is 3. So 3 is my key element. Key element is equal to 3. So now you can find the key row values. 3 key row means old value by key element. So 3 by 3 is 1 and 1 by 3 and minus 1 by 3, 0 by 3 is 0, minus 1 by 3, 0 and 2 by 3. And you can find the non-key row values. This is non-key row values. You can find the non-key row values using the formula called old value minus corresponding key column also minus 1 and key row is 3. I'll repeat. Formula is old value minus corresponding key column into key row divided by key element. Old value is minus 1 and corresponding key column also minus 1 and key row is 3 divided by key element also 3. So you'll get 0. And old value is 1, corresponding key column is minus 1 and key row is 1. You'll get 4 by 3. And old value is 1. Corresponding key column is minus 1 and corresponding key row is minus 1. So, you will get 2 by 3. And old value is minus 1, corresponding key column is minus 1 and key row is 0. So, answer is minus 1. And old value is 0, corresponding key column is minus 1 and key row is minus 1. Answer is minus 1 by 3. And old value is 1, corresponding key column minus 1, corresponding key row is 0. Answer is 1. And last value is 1, old value 1, corresponding key column minus 1 and corresponding key row is 2. Answer is 5 by 3. So now you can find ZJ value. ZJ value 0 into all the numbers are 0 only. So minus 1 into 0, 0. Minus 1 into 4 by 3. Minus 4 by 3, minus 2 by 3, minus 1 into minus 1, plus 1, minus 1 into minus 1 by 3, 1 by 3, minus 1 into 1 is minus 1, and minus 1 into 5 by 3, minus 5 by 3. So find Cj minus Zj, 0 minus 0, 0 minus of minus 4 by 3, and this 2 by 3, 0 minus 1, it is 0 minus 1, it is minus 1. 0 minus 1 by 3, minus 1 by 3, minus 1 plus 1, it is 0. Now you can check whether it is satisfying the optimality or not. So in phase 1, all the Cj minus Zj value should come 0. Till then we can do the iteration. So next iteration. Here you have to select the key column and key row. So maximum positive value is 4 by 3 comes under. So x2 is my key column. Now we can find the ratio value 5 by 3 solution by 4 by 3. So 5 by 3 divided by 4 by 3. 3 get cancelled, it is 5 by 4. And 2 by 3 divided by 1 by 3. 2 by 3 divided by 1 by 3. 3 get cancelled, it is 2. So now you can find the least positive value. 5 by 4 means it is 1 by 2. So, you have to select the least positive value in the ratio. So, least positive value is 1 by 2. So, this is my key row. Key row is A1. So, you can observe this. So, here A1 is my living variable and entering variable is x2. x2 is my entering variable and key element is 4 by 3. Key element is equal to 4 by 3 for next iteration. So, you can find the next iteration, iteration 2. So, I am replacing this A1 by x2. So, I am deleting this A1 and also I am deleting this A1 column. I am deleting this A1 row and A1 column also in the next iteration. So next step is phase 2. So in phase 2, you can write the original coefficient value in your objective function. It is minus 10, minus 6, minus 2, 0 and 0. So variables x1, x2, x3 and s1, s2, solution and ratio. So definitely in phase 2 you'll get the optimal solution. In phase 1 I got x2 and x1. So I have deleted a1 and a2 artificial variable I have deleted in first phase only. So x2. So x2 coefficient is minus 6 and x1 coefficient is minus 10. So using the old values in phase 1, I can write the new value here. So no need to change anything because there is no entering variable and leaving variable and there is no key element. So here I am using only the old values and I am finding the optimality condition. So I will fill the old values here. So my old values are 0, 1, 1 by 2, minus 3 by 4, minus 5 by 4 and 5 by 4. And in second row, I have 1, 0, minus 1 by 2, 1 by 4 and minus 7 by 4 and 1 by 4. So now you can find Zj value. So what is Zj? Minus 6 into 0 plus minus 10 into 1. So it is minus 10. And minus 6 into 1, it is minus 6. Minus 6 into 1 by 2 plus minus 10 into minus 1 by 2. So you will get 2. And minus 6 into minus 3 by 4 minus 10 into 1 by 4. You will get 2. And next is minus 6 into minus 5 by 4 minus 10 into minus 7 by 4. You will get 25. You can calculate this, take LCM and find the values. And minus 10 into 5 by 4 minus 10 into 1 by 4 will get minus 10. So here we got the value of Zj. You can find Cj minus Zj now. So minus 10 minus of minus 10. So minus 10 plus 10 is 0. And minus 6 minus of plus 6. It is 0. And minus 2 is minus 4. And 0 minus 2, minus 2. 0 minus 25, it is minus 25. So here we got the negative value as well as 0 in the last iteration, that is phase 2. So in phase 1, we'll get all the 0 values and we have to use the 0 coefficient except the artificial variable. So after finding the phase 1, we can find second phase, phase 2. So in phase 2, we will get 0 and negative value. So here max z is equal to minus 10. So what is x1? x1 is equal to 1 by 4 and x2 is equal to 5 by 4. Now we can cross verify the answer. Max z is equal to 10 minus 10. So minus 10 into 1 by 4 minus 6 into 5 by 4. So now you can cross verify the answer. Minus 10 is z value, max z is equal to 10 and minus 10 into x1 is 1 by 4, minus 6 into x2 is 5 by 4 and 2 into x3 is not there, it is 0 and 2 2s are 2 5s are, it is minus 5 by 2 minus 2 2s are 2 3s are, it is 15 by 2, 2 is the LCM, so it is minus 20 by 2, it is minus 10. So minus 10 is equal to minus 10, LHS is equal to RHS. So it satisfies the optimal condition. So optimality condition is satisfied in second phase. So in first phase, you have to use only the 0 coefficient of all the objective function except artificial variable. So definitely in second phase, you will get the final answer. So this is about your two-phase method. So first you have to practice the simplex method, then you can implement two-phase method and B.C.A method also. So this is about your two-phase method. In my next session, I will come with a new concept called degeneracy in LPP. Thank you.